Okay, so hi everyone. So welcome back to the second video of this digit DP playlist. So today in this video we are going to do this problem from Leetcode that goes by the name number of digit 1. Before starting this video, if you have not yet watched the first video of digit DP that I just uploaded, please go back and watch this video first, because in this video I have covered all the basic things and introduction part related to the digit DP. So if you are watching this concept for the first time, then I will suggest you to watch this video first and then only come back to this video. But if you already know the basics, then you are good to go with this problem now. So let us start with the problem. So the problem reads like this, that you will be given an integer n and you have to count the total number of digit 1 appearing in all the non-negative integers less than or equal to n. Let us first try to understand why is it a question of digit DP. So as I explained you in the previous video, that how to identify if a question is digit DP or not. So first you have to look in the constraint. So if you look in the constraint here, then as you can see it is going up till 10 to the power 9, right? So which is quite high. So this is the first indicator. Second thing is that you have to return the count of only specific digits in a range. But where is the range here? So we saw in the previous video that a range was given directly, but here the range is not given directly. So you are only given with this integer n, but you are also told here that you have to return the count of digit 1 appearing in all non-negative integers. That is, all integers were positive in this range. That is, all integers will start from 0 and will go all the way till n, right? Because it is written that less than or equal to n but non-negative, that is from 0 till n. So that's why the range is not given here directly, you have to identify it, right? So once the range is clear and the constraint is high and you have to return the count of some specific digits, that's why it is a question of digit DP clearly, right? So once it is clear that it is a digit DP question, let us move forward with the example part. In the first example, as you can see that the value of n is 13 and the expected output is 6. So let us now try to understand why the expected output is 6 for this n equal to 13. So let us now go to the blackboard. So this is the first example where n is equal to 13. So as I told you that the range for this will be nothing but, if I write here, then the range for this will be from 0 all the way till 13, right? So you have to check for each and every integer present in this range. So if I write all of these integers one by one here, let's see what will happen. So as you can see that I have written here all the integers present in this range. Let us now start counting from the very start and try to see how many digit 1 is present particularly, right? Because you have to count the digit 1 count, right? If we start from the 0, then clearly in this 0th integer there is no digit of 1. So that's why this will not be a part of our answer. Let us move forward. Now we are standing at this one, and clearly for this one there are total of 1 digit for which the digit is 1, right? So that's why this will contribute a +1 to our answer. And then if we move forward, then we have 2 here in which there is no digit 1. Similarly in this 3 there is no digit 1, and as you will move forward then you will realize that till 9 there is no integer in which a digit 1 is coming. So these will not contribute anything to our answer, right? So let me cross mark to each one of them, right? But as soon as you reach 10, then there is one digit which is of 1 value, so it means that it will again contribute +1 to our answer. And if we move forward now, so we will reach 11, and in 11 integer there are 2 digits having a value of 1, so +2. And again if we move forward, so this is done. So after moving forward we will reach 12 and then 13, for both which there is only one digit of a value of 1, so that's why +1 for each one of them, and in this way they will also contribute to our answer. So if you sum up this value, then what is it equal to? So 1 plus 1 2, 2 plus 2 4, 4 plus 2 6, right? So the total value it should return is 6, and that's why the expected output is also 6 here, as you can see. So I think the problem requirement is very straightforward. And if you look in the second example, then the value of n given here is 0, since in the constraint the value of n can go up till 0 till 10 to the power 9, right? So n can be 0 as well, and if n is 0, then it means that the rightmost value is 0 and the leftmost is also 0. So the range is nothing but 0 till 0, and we know that from 0 till 0 there is only one digit which is 0, in which no 1 is present, so that's why the output is also 0. I guess the problem is completely clear to you now. So let us now try to understand in the blackboard what specific logic we will apply in this. So in order to make you understand things better, I am considering a value of n here by myself. So let us consider the value of n as, let's say, 471819, right? So if this is the value of n, because the value of n can go up till 10 to the power 9, right? So since this integer here is having a total number of digits equal to 6, so this is the first digit, this is the second digit, third, fourth, fifth and sixth, so the total size of this integer is 6, right? So that's why here I have considered 6 different blocks also, right? So we know that since the range here, if I write, the range is nothing but 0 till then 471819, if this is the value of n, right? So it means that if I want to fill these 6 blocks, then it can be something like starting from this 0, that is all the blocks will be 0, right? And then increasing one block by each time and ultimately reaching this, that is 471819, right? And for all such integers we want to count the number of digit 1. So let's see how we will do it. So we know that what technique we apply in these types of questions, right? So what we do is, since we have to check for each of the digit present in this range, that's why we will try to check for each and every digit. That is, we will try to check out each and every possibility starting from the leftmost part and going till the rightmost part. And if you remember that prefix sum logic, then I also told you that first we try to calculate for the rightmost part, then we subtract the value for the one less than the leftmost part, right? But here that won't be the case, because once we solve it for the rightmost part, then earlier what we used to do, we simply subtract the leftmost minus 1, right? But since here the leftmost part is 0 only, and we already know that what answer will be there for this part, right? Because for each and every example the value of this part will nothing but 0. We are starting from 0, and from starting from 0 and going till 0, the total number of digit 1 will be nothing but 0 only, right? So we already know the answer of this part and it will not contribute to our actual answer. So that's why we will not focus on this. We will only focus on this part. That's why we are only focusing on this rightmost part. So if you remember, then what we used to do, we used to start from the most significant bit here, that is from this side, and go all the way till this side until the value of index becomes equal to the total size of this integer, right? So let me give you a quick overview. So what we used to do is, we used to start from this index, that is the 0th index, and as we move forward one index each time, right? And as soon as the integer is completed, we used to compare the size. That is, if the size of this integer, which is 6 here, becomes equal to the index, that is this 6, so in this way we will realize that the integer has been formed successfully without causing any issue, and that integer will be a valid integer in that range, right? So here also we will do the same thing here, nothing fancy. So suppose now I want to fill this part, that is the first block. So if I want to fill this block now, then what choices do I have? So if we look here in the original value of n, so for the 0th index, the value of this 0th index is nothing but 4. And also we have to convert this integer into a string, then only we can access each of these digits by their index, right? So this will be nothing but a string only, right? So keep this in mind. So if I also write the indexing here, so 0, 1, 2, 3, 4, 5, right? So once we are standing on the 0th index, then we know the actual value is nothing but 4. That is, if you want to fill this block, then it can only take values starting from 0 going till 4, right? It cannot take any value greater than or equal to 5 and less than or equal to 9. So it cannot take any value like this. It can only take between 0 all the way till 4. That is, the condition for this starting block should be tight. So that's why the value of type that we will pass initially for the first block will be true. And why? I just told you. Because there can only be certain limited digits that we can fill in this block and not every digit. Suppose we decided to fill it with 4 only. Because we had the liberty to fill anything from 0 to 4. So suppose we filled it with 4. and once we fill it with 4, we will move to the next block, right? And since we have already filled it with 4, it means that we are not allowed to select anything randomly for this next block now, that is for the first index, because if we select anything, let's say something like 8 or 9, then ultimately the whole digit will anyhow become greater than this rightmost limit, which is not true, we know, right? So that's why now again we have a restriction to select anything between 0 till 7, so we can only select this now. So suppose now I will break the tight condition, that is, since I am allowed to select anything from 0 to 7, so suppose I will select the integer, let's say 1, right? So if I select 1 here, then I will write here 1, and once I have written here 1 and I will move to this next index, then clearly in this whole part, whatever digits I will fill it with from 0 to 9, this whole integer will never be able to get greater than this and will always lie in this range, which will be a valid one, right? So that's why now I have the liberty to choose anything between 0 to 9 for all of these 4 blocks. Got it? So that's why I can choose 0 to 9 for this block, 0 to 9 for this block, 0 to 9 for this block, and 0 to 9 for this block, right? So suppose I chose the digit 2 here, because I can choose anything between 0 to 9 now. And once I have decided to choose this as 2 and move to the next index, again I have the choice to fill it with anything from 0 to 9. So let's say I filled it with, let's say, 1, and again I will move forward to the next index, and again I have the liberty to choose anything from 0 to 9. So let's say I again filled it with 1, and then again I will move to the next index, and as soon as I reach this last index, again I have the liberty to choose anything from 0 to 9. So let's say I choose something like 7. Then I will get out of it, that is, the value of index will now become equal to 6. And once we will see that the value of index, which is 6 now, has become equal to the length of this integer, that is 6. So in this way we will realize that whatever integer should have been formed is now formed, right? And no more digits must be added to this integer further. And in this way, by the end of this, that is after reaching the 6th index, we will see what is the count of 1. So how we will realize this count of 1? So we will use a state for it. So how many states will be required? I think you must have guessed now. So the first state that will be required here will be our index state, because each time we are moving forward, then the index is getting increased by 1, right? So that's why index is getting changed. So that's why this will be our first state. What will be our second state? So clearly, since at each block, whenever we are standing, then we have to decide whether we can fill it with each and every value from 0 to 9 or not. So how we will decide this? So initially the value of type will be true, and I told you why, because we can only fill it a limited set of values starting from 0 and going till this digit, right? Because there was nothing present before. But as soon as we decide the digit value for this 0th index, if it is equal to this original value, that is the upper bound value, then it means that for the next block also the condition will be tight. That is, we can only select from 0 to 7 and not 8 or 9. But if we decided to not select this as the upper bound value and less than it, let's say 6, then we know that the value of tight will be broken now, and now whatever digit we choose for this part, we can choose anything from 0 to 9. So for this part, in that case, tight will be turned to 0. So we already know these things from the previous video, right? So that's why this tight will be our second state. So these two states are almost compulsory in every digit DP problem, right? So once these two states are decided, let us now try to think what one more state is required. So what does the problem want us to calculate? It wants us to calculate the total number of ones actually, right? So once we will reach this 6th index, we must count the total number of ones present in the formed digit. So since here this is 1, this is 2, and this is 3, so there are a total of 3 digits for which the value of digit is 1. So that's why we will add plus 3 to our answer. So that's why we will use a third state here, and let's name it as something like count of 1, right? So we can name it like this because this state will hold the count of 1 at any specific given time. So suppose we started initially, right? And initially the count of 1 will be 0 obviously, and as soon as we decide the value for this index, block rather, so since we can have chose anything from 0 till 4, so here I chose 4, and since I chose 4 which is not equal to 1, so it means that we will not add +1 to the count, and whatever the count value was present before, we will only pass the same thing to the next block. But here I chose 1, and since I have chosen 1, then whatever count value was already present till this part +1 will go to this block now, because I chose 1 here, right? So that's why the value of this state, that is the third state, that is this count of 1, will be 1 by here. Once we are present on this second block, we will see whatever the count value was already there in the state, so it will be 1, plus since here I have chosen 2 which is not equal to 1, so the count value will remain same as that of the previous, that is 1 only. So that's why it will pass 1, and that's why the value of count of 1 will be 1 here. But as soon as we will try to move to the next index, so it will see whatever the count value it already had. So it had already had 1, right, which came from this, and again we are choosing 1 in this block, so that's why it will pass 2 here, and the same thing will continue for this block also. So it will see that the value of count for this part is 2, right, and the digit here selected is also 1, so that's why 2 plus 1 3, so it will pass 3. And once we reach this last index, it will see what the count value already had. So it already had a count value of 3 for this third state, plus since here I have chosen 7 and not 1, so that's why it will say something like 3 plus 0, and it will pass this value to the next index. So that's why when we will reach this 6th index, it will see the value of this third state as nothing but 3, and that's why it will add +3 to our answer. And this whole thing that I told you will be applicable to each and every integer present in this range, because each and every possible combination will be tried, right? And that's why the answers will get added each and every time, and finally we will just return that answer. That's why this is a question of digit DP, and we will apply almost the same trick and the technique that we applied in the previous question. So now I think it will be very good for us if we move to the coding part and actually code this up, and then we will see how we can memoize this same recursive solution so that we can get accepted on the platform. So let us move to the coding part. Okay, so the first thing that I told you to do was to convert this given n into a string, right? So let us do the same thing. So let's name this string as s. So just apply the standard HTL here. Once we have converted the given value of n into a string, let us call the required function. So let's name this function as something like solve function, and I will just pass this string s, right? And whatever value it will return, I will simply return it from here, right? So this, and let us now try to write the solve function here. So since it will return an integer value, so that's why I will write it as int only, and the name of this function is solve, and the first parameter here is this string s, right? So what I told you that first we will start from the 0th index, right? So that's why this will be our first state as well. So this is nothing but idx, and since we also have to pass the value of type initially, which is true, because we cannot choose anything freely between 0 to 9, so that's why this will be bool of type, right? And once I have written these two states, I also told you that first initially the value of count of 1 will be 0, right? So the value of count of 1 is 0 initially. So if I write here, then I will say that count of 1 initially is 0, right? So these are the three states that will be required. So what will be the base case? So the base case will be very simple, as I told you, that when the value of this index will become equal to the size of this integer, that is s dot size, then what we will do, we will simply return this value of count of 1, because by now it must have been holding the correct value of the number of all the digit ones present in this formed integer, right? So we will just return this. But if it is not the case, then what we used to do, we decide the lower bound and the upper bound, right? So clearly the lower bound is 0 and the upper bound will be decided by the value of type. So if the value of type is true, then it means that we cannot choose anything freely, that is we can only take up these values, that is this. And if this is not the case, then it means that we are free to choose anything, so 9. So if I write the for loop here, the digit value we can select will start from this lower bound and it will go all the way till this upper bound, something like this, and will get increased 1 by every time, right? And since for each of these integers lying between lower bound to upper bound, we are allowed to select anything, right? There is no restriction unlike the previous question. So that's why we will directly add it to our result, right? So if I declare the result variable here, initially it will be holding a value of 0, right? And I will again call the same solve function here, and this time the string will remain same, but this index value will get increased by 1, and this type value will depend. And how it depends, I have already told you in the previous video. So if the value of type was true till now, right, and the current digit that I have selected is equal to the upper bound, so if this is the case, then it means that for the next block also the condition will be tight, so this. But if it is not the case, then it will return false, and then we will be allowed to take up any value from 0 till 9. And the next thing will be to decide the value of this count of 1 for the next iteration. So whatever the count of 1 value was already present till now, plus if the current selected digit is equal to 1 or not. So if the current selected digit is equal to 1, then it will add up to the already existing count of 1 and will pass it to the next iteration. And then we simply have to return this result, right? So I think I have written the code here. So if I try to run it, let's see what happens. So as you can see here, both the test cases are getting passed, so our solution is correct, right? But there is one problem. Since the constraint is very high, so it means that we have to memoize it. This recursive solution will definitely give you a time limited exceeded, right? And it already gave when I submitted, so that's why it is important to memoize. So let's memoize it quickly. So let's do a meme set here for the dp states. So meme set dp minus 1 size of dp, and let us try to declare the states now. So as I told that there are only 3 states, so this is the first state, this is the second state, and this is the third state, right? So these 3 states are there, and if the dp value of this is already present, then we will just return it, right? But if this is not the case, then whatever it will calculate for this iteration will be stored, right? So this, and let's try to name this states here. So this is index idx, this is tight, and this is nothing but count of 1. In this way the solution will be memoized. Let's now try to decide the sizes for each of these states. So since the first state is this index, and the value of n can go up till 10 to the power 9, right? So since the value of n can go up till 10 to the power 9, that is 1 plus 9 such zeros, that is a total of 10 digits, and in order to access the 10th index you must declare a size of 11, right? So that's why this will be nothing but 11. And the second state is this bool tied. So since it can only take 2 values, that is 2 and false, so that's why it will be 2. And finally the count of 1. Since the value of n can go up till 10 to the power 9, that is 1 and so these 9 zeros. So the value of n can go up till 10 to the power 9, which is this. So the maximum number of ones that can be present in this will be nothing but this first digit will be 0, and remaining every digit will be 1. So maximum this would be the case, right? So this will be the maximum case, that is 1 2 3 4 5 6 7 8 9. So a total of maximum 9 ones can be present, right? So in order to access this 9, we must declare a size of 10 at least. This will be nothing but 10. And now if I try to run it, let's see if this solution is correct or not. So as you can see that both the test cases are getting passed for the solution that I just wrote. And now if I try to submit it, let's see. So as you can see, our solution is 100% correct and has been submitted successfully. This is the code that I just wrote and explained you each and everything in very detail, what is the logic behind all this. I know I was a little fast in this video today, but since I already have covered all the basic things in the previous video, so that's why I don't wanted to repeat the same things again and again, and that's why I was a little fast. But I believe that it was easy question as compared to a previous video, so that's why it was not much of a difference. So as you can see that the structure of this function also is very similar to the previous question, right? thank you so much for watching this video till this point. If you really think you understood something new or knowledgeable that can be helpful in your interviews or any online assessment, so please consider liking this video and subscribing this channel if you have not yet subscribed it, because there is a lot of amazing content present here, as you can see. And currently there are a total of 3 playlists. So the first playlist I created was this advanced graph series consisting of approximately 14 videos, and in this segment tree series consisting of the 9 videos. And now I'm making this digit DP series, right? So yeah, if you want me to make this quality videos on a regular basis, please consider subscribing the channel, because it takes a lot of efforts to create every video, right? So yeah, thank you so much for watching this video. Thank you.